These are the important things to know before conducting a test of hypothesis. Level of significance. Types of tests. Test statistic. Critical region. Critical value. In hypothesis testing, the decision to reject or not to reject the null hypothesis is called significance and is based on the set criterion called the level of significance. The level of significance alpha is the probability of committing a type 1 error. This is the probability of rejecting the null hypothesis. Some common values used for the level of significance alpha are 0.1, 0.05, and 0.01. For example, if alpha is equal to 0.1 and the null hypothesis is rejected, it means that we are 90% certain that the decision for rejecting the null hypothesis is correct. If the problem does not specify any level of significance, the default value is used, which is 0.05. The probability of committing a type 2 error is the probability of not rejecting a false null hypothesis. In other words, it is the probability that the test statistic will be the non-rejection region if, in fact, the null hypothesis is false. It is denoted by the Greek letter beta to denote the probability of a type 2 error. The probability, beta, of a type 2 error depends on the value of mu. There are two types of tests, a one-tailed test and a two-tailed test. A one-tailed test is done when the alternative hypothesis is directional, which means that the value of the measures is either greater than or less than the other measure. It can be a left-tailed test or a right-tailed test. A two-tailed test is done when the alternative hypothesis is non-directional, which means that the value of the measure is not equal to the other measure. The test statistic is a statistic used as a basis for deciding whether the null hypothesis should be rejected. This is the value generated from the sample data. This is the test value to be compared with the critical values. The table shows the appropriate test statistics for the different scales of measurement. The critical region divides the region into rejection region and acceptance region. The rejection region, area or region of rejection, are the values of the test statistic that leads to rejection of the null hypothesis. While the non-rejection region, area or region of acceptance, are the values of the test statistic that leads to acceptance of the null hypothesis. The critical region depends on the type of test to be performed. If the test is one-tailed, then the critical region is concentrated on either the left tail, or less than, or the right tail of the distribution, or greater than. If the test is two-tailed, then the critical region is distributed on each tail of the distribution. The critical values are obtained depending on the type of test to be performed. If the test is one-tailed, the level of significance alpha will be the area either on the left or on the right tail of the distribution. If the test is two-tailed, the area on each tail of the distribution will be alpha divided by 2. The critical value is the value of the test statistic that separate the rejection and non-rejection regions. Figure 1 shows the regions in a normal curve when a two-tailed test is used. The shaded areas are the regions of rejection. That means, when the computed value falls in the area of rejection, the null hypothesis is rejected. Figure 2 shows the regions in a normal curve when a right-tailed test is used. The shaded area is the region of rejection. That means, when the computed value falls in the area of rejection, the null hypothesis is rejected. Figure 3 shows the regions in a normal curve when a left-tailed test is used. The shaded area is the region of rejection. That means, when the computed value falls in the area of rejection, the null hypothesis is rejected. Let us have examples on how to determine the type of test to be used. Formulate the null and alternative hypotheses of each claim. Then, determine the type of test to be used. The percentage of junior high school students who passed math during summer was 65%. The null hypothesis is the percentage of junior high school students who passed math during summer was 65%. The alternative is the percentage of junior high school students who passed math during summer was not 65%. The alternative hypothesis is non-directional. Therefore, the type of test to be used in this situation is two-tailed. On the average, there are at least 5 typhoons that hit the country every year. The null hypothesis is the average number of typhoons that hit the country every year is 5. The alternative is the average number of typhoons that hit the country every year is less than 5. The alternative hypothesis is directional, with a quantifier of less than. Therefore, the type of test to be used in this situation is left-tailed. In the rural areas, at most 6 out of 10 married women are housewives. The null hypothesis is in the rural areas, the percentage of married women who are housewives is 60%. The alternative is in the rural areas, the percentage of married women who are housewives is greater than 60%. The alternative hypothesis is directional, with a quantifier of greater than. Therefore, the type of test to be used in this situation is right-tailed.